Hello, everyone, and welcome to today's webinar. Thank you very much for joining us. So good morning or good afternoon or good evening to you, depending on where you're at in the world. So our webinar today is From Promise to Reality, how wind and solar operators are using AI-enabled asset management tools. We've got a fantastic group of speakers for you today. Got a lot of excellent material. I think you're really going to enjoy the presentation today. I'll go over the agenda in the next slide here. So what we're going to talk about today, each of the speakers, I'll introduce each of the speakers, and we'll also introduce the two companies that are participating in the webinar today. We're going to go over the benefits of AI-enabled asset management. We're going to talk about the Energy.ml asset management platform architecture. That's Ensemble Energy's asset management platform. We're going to give some specific wind use case examples. We're going to give some solar use case examples. We're going to do a product tour of the Energy.ml platform. Then we're going to have a panelist discussion. And then finally, we're going to have an audience Q&A. So there is a Q&A a panel available to you. You can submit your questions at any time. We do have people standing by. Some questions might actually be able to answer in real time, but we're going to reserve 10 minutes at the end of the hour for audience Q&A. So with that, we'll go ahead and get started. I'd like to introduce the webinar speakers. So we have, again, a really fantastic panel today. One speaker is Dr. Sandeep Gupta. Sandeep is the CEO and co-founder of Ensemble Energy. Sandeep has over 15 years of renewable energy experience, including 8 years at a wind turbine OEM, 3 years leading a wind turbine consultancy before he co-founded Ensemble 3 years ago. Sandeep holds a PhD in aerospace engineering from the University of Maryland College Park, where his research specialty was wind turbine aerodynamics. Another speaker we have is Nick Siddons. Nick is Director of Operations at Renew. Nick's been in the wind industry since 2000, started working on construction management. He spent the past 10 years in the O&M space managing multiple service centers, and he currently oversees Renew's full scope operations portfolio, as well as Renew's electrical division. We also have a speaker, Wade Weichman. Wade is a technical director at Renew. Wade's been in the wind industry for over 20 years. He began his career as a technician, where he developed hands-on experience. He's actually been with Renew since 2009, and Wade's expertise expands control system design, programming, SCADA system development, and wind turbine optimization. And finally, I'm also speaking today and acting as a moderator. I'm Rob Budney. I'm the COO and co-founder of Ensemble Energy. 18 years in rotating equipment reliability, past 16 years in wind. My area of expertise is gear and bearing reliability. So let's go ahead and get started. First, I'd like to just give you a very brief introduction to Ensemble Energy. Ensemble was founded in 2017. Our headquarters is in Silicon Valley. We do have an office in India. We have an office in Brazil. Our team is almost evenly split between energy domain experts and data science and software experts. Our belief is that the data science piece is very important. We want to have the best data scientists that we can possibly get, but we really feel that the domain expertise is just as important. And if you don't have the domain expertise, you're not going to be able to unlock all the value that's in the data. We are currently monitoring about 3.5 gigawatts of wind assets, 500 megawatts of solar assets being monitored, and both are growing very quickly. Nick, you want to give an introduction to Renew?
Yeah, thanks, Rob, and thanks for the opportunity to participate today. Renew was founded in 2009 by wind energy veterans. We're actually at just under 300 employees right now. Headquartered in Sioux Falls, South Dakota. We have offices in 6 states, mostly in the Midwest, but we do have a branch field office in Washington and in Texas. Gives us a nationwide footprint. We offer a full spectrum of services to the North American wind and solar market. What people may know us best for would be drivetrain remanufacturing. That happens in our Sioux Falls, South Dakota remanufacturing facility. We do have a 3 megawatt test stand there for full load testing of remanufactured drivetrains. Kind of related to that, we have an extensive portfolio of in-field drivetrain repairs. We're very proud of our suite of in-field gearbox repair services that we've developed over the years. We also do a lot of installation, commissioning, and related field services. That would include construction services, customer representation, quality control services, things like that. What we'd be focusing on today, our operations and maintenance, also what I deal with. Our O&M activities are mostly focused in the upper Midwest, South Dakota, Minnesota, Iowa. And along with that, we have our NERC compliant control center services. That's our 24/7 ops. That's also housed in Sioux Falls, South Dakota in our corporate office. Some of our divisions people might not be as familiar with: composite repair, in-place blade repair, gearbox oil change services, inspection services, and we do also have a commercial electrical division. So kind of a brief overview of Renew.
Well, thank you very much for that, Nick. And we've had the good fortune of working with Renew in many of these areas. We've worked with Nick in terms of the operations and maintenance, and we're actually going to talk about some of the ways that we've worked together with Nick. We worked with Wade on the control center piece. Again, as I mentioned, my particular area of expertise is gear and bearing reliability. So in that capacity, I've had the good fortune to work with Renew on their drivetrain remanufacturing, also the main bearing repair. And I can say that our experience has been nothing short of fantastic. I mean, all the people at Renew are top notch. They're very customer focused. And so, we definitely recommend Renew and these services quite highly.
We appreciate that, Rob. We're proud of what we've done, that's for sure.
Well, it shows. Pleasure to work with you guys. Okay, so the next thing we want to talk about is what are the benefits of AI-enabled asset management? And we listed them here at a high level, not really in any particular order. But one of the benefits that you get when you're using an AI-enabled asset management platform, you have improved access to data. As you'll see when we go through the products tour, we're pulling together multiple sources of data, putting it into a place where it's easy to access and giving users tools to easily interact with the data. Another big benefit is the automation of repetitive tasks. This really comes down a lot of times to reporting. We find that customers spend many hours on a weekly basis, on a monthly basis, on a quarterly basis, generating the same report. They have to pull information from multiple sources. And it's just, it's not really the best and highest use of their time. If you have access to an AI-enabled asset management platform, all of this reporting can be automated, can be scheduled in advance. So it really results in very high time savings. Also changes the nature of work from reactive to proactive. So rather than waiting until you have a pitch bearing fail, for example, and then start taking steps, if you can get a heads up that, hey, you've got 3 pitch bearings that are going to fail in the next 6 months, you can start working, getting those parts on order, getting the crane on order. So it really changes the paradigm of the work from reactive to proactive, provides improved visibility into the future state of assets, increases availability and production, and results in reduced O&M costs, both planned and unplanned. Here I'd like to just share the high-level Energy.ml platform architecture. Again, Energy.ml is the AI-enabled asset management platform that Ensemble supports. That's our tool. Starting from the left and kind of moving to the right, showing some of the data sources that we've pulled in. So we'll pull in the power pricing and the TSA information. We'll bring in historical SCADA data. We'll bring in real-time SCADA data as well. We also want to bring in the parts usage information. That's also really important. By having access to the parts usage and the maintenance information, we're able to minimize the false positives. If a maintenance action occurs, it can affect the accuracy of our machine learning models. If we know that a part has been replaced, we can build that information into the machine learning model. Now, the CMS piece, this is not strictly necessary. We can build many of our models without CMS information, but if CMS is available, we bring that into our platform as well, too. In addition to the actual signals that we bring into the platform, we also create physics-based digital twin models. So for example, each of the turbines that we work with, we will build a loads model for that turbine. So under a given condition, we know what the rotor thrust is. We know what the overturning moment is. That's just one example of a physics-based model. We have several others as well too. So we combine the actual signals with what we call a virtual signal, bring that information out to our cloud platform, run our data analytics on the signals, serve customers through our energy.ml platform, provide prescriptive action, work order management, BI dashboard. When a customer takes an action based on the notification, they will also report their findings through the platform. So that way we're able to close the loop. So we're able to tell the machine learning algorithm, yes, the prediction you made was accurate. No, the prediction you made wasn't accurate. And so we can continually be improving the accuracy of the algorithms over time by closing the loop. A little bit of the platform capabilities. So we do predictive analytics, data visualization. Again, we provide a unified data lake for all of the data, automated reporting, really good tools for optimizing energy production. We have some tools for maintenance planning and tracking, and also some energy forecasting capabilities. A little review here, or discussion of our AI model pipeline. So we've got a couple of figures here. The figure on the top shows a deep learning model that we use. So this is a neural network model. This is a framework called Inception. We have applied this framework to some time domain signals with a lot of high accuracy. We develop all of our own machine learning algorithms, so we're not using anything that's off the shelf. We pair our top-notch data scientists with domain experts, and we write our own and we develop our own proprietary machine learning algorithms for wind energy projects and for solar projects. We're able to combine data on multiple timescales. Could be 10-minute data down to vibration data, which comes in at a much higher frequency than that. And in addition to developing really accurate machine learning models, we also have developed the tools and the infrastructure to serve the results of these models to our customers and to continue to tune and maintain the accuracy of the models as well. Now we're going to start sharing some use cases. We'll start with some wind energy use cases. So we'll start with that figure on the left. That's actually a physics-based methodology that we use to detect turbines that have yaw errors. So that's a really accurate way of identifying turbines with yaw errors. The downside to that is you need a lot of data. So you need usually about 12 months of data. So what we do is we start with a physics-based method, which is shown, and then we tell the machine learning models which turbines we have found with a yaw error. So we turn that into what's called a supervised learning problem. And then once we've done that, we're able to identify future yaw errors very quickly. We only need about 2 months of data, and we can identify turbines with yaw error of 5 degrees or greater with about 96% accuracy. Another thing that we can do with our machine learning models, the picture in the middle shows one of our customers who had worked with the turbine OEM. The turbine OEM had put in a software which was claimed to increase the power production of the turbines. We were able to use our machine learning algorithms and to quantify the performance improvement, and actually in some case performance decrease of the turbines as a direct result of the software change. We're able to isolate all of the other factors and just really identify what the change was from the change in the software. And then finally, we have automated ways of identifying underperforming turbines. So our machine learning algorithms are running on the cloud 24/7. They're constantly monitoring these thousands of turbines. When they identify a turbine that is not performing as it should, our customers are notified, and then our customers can use our data analysis tools to dig in. In this case here, we're showing a torque speed curve, and we're seeing a turbine that had a parameter issue, which resulted in a lower power performance. Here's an example that a lot of you are probably familiar with. Here we're talking about the pitch bearing cage failure. So the failure progression, it starts as shown in the figure on the left. You'll get some rubbing on that cage. That cage will rub on the lands of the bearing outer ring, which will reduce its thickness. And then what happens is you got multiple segments inside the bearing. These segments will overlap and they'll pinch, which will cause a binding. That binding will cause a very high force, which then the ball will actually cause the cage to fracture. So we're able to identify these failures very accurately 6 months before a functional failure. What's shown on the bottom right there is what we call a health score. So we create health scores for each component that we're monitoring. Here we can see this health score declining over time, giving our customer plenty of time to get pitch bearings on order, to schedule cranes, and to really minimize the crane mobilization cost and also minimize the downtime. Another example, main bearing failure prediction. Again, many of you are aware of this. The figure on the middle, in the top middle, shows the outer ring spall failure mode. The figure on the lower right shows sort of a kind of a more recent failure mode on main bearings. It's a axial crack, the same failure mode that's been so devastating in wind turbine gearboxes. And we can accurately predict these failures either with or without CMS. So if we have CMS data, we can bring that into our algorithms. If we don't have CMS data, we can use other signals, bearing temperature and other signals, and identify these failures well in advance. In some cases, we can identify issues with the lubrication, where there's poor lubrication inside the bearing. That can allow our customers to actually take a maintenance action, which will either completely prevent the failure or at the very least significantly prolong the life of the bearing. Some examples here of our solar capabilities. So solar farm performance can be affected by multiple factors. The figure on the left shows an inverter performance correlation matrix, where we can see that inverter 6 has an issue. The performance of inverter 6 is not correlated to the other inverters as you would expect it to be. The figure on the right shows some soiling detection. So we've got some performance ratios there. We can see that the performance ratio has been declining. We can see that a cleaning action was taken and the performance ratio increased. We have machine learning models which are constantly looking at these performance ratios and can accurately kind of pick out that signal from the noise and identify when a solar module is underperforming, and then suggest what is the most likely corrective action for the issue. Next, I'd like to show, this is an example of our automated energy loss analysis. So what the platform is doing is it's constantly looking at all of the turbine event data, figuring out which fault was the primary fault, and then using a combination of a neighbor analysis and machine learning algorithms, we're able to actually calculate how much energy was lost from each fault and show that to customers in an automated fashion. So there's actually absolutely no customer input which is required here in order to generate this plot. And the total lost energy for this period of time for this project is shown, and then it's categorized by component. So you can see that the frequency converter is causing the greatest amount of lost energy, followed by the pitch system, and so on. So what this does is it allows operators to really understand where they are losing energy and where they need to focus their efforts to increase the availability, to maximize availability, and to maximize the power production. Next, some examples of some automated reporting. So the platform automates both the creation and the distribution of recurring reports. Showing here just a few of the things that are typically included in the reports. So showing power curves for each turbine, a summary of failures or downtime analysis, showing information about for a solar project, how the inverters are performing, showing site availability. We actually have a lot of financial metrics as well too. So the image in the lower middle shows actual versus budgeted production. We have that for revenue and a lot of other financial metrics as well, or just showing the site environmental conditions. So for example, looking at the solar irradiation for a particular project. So these reports are very powerful. They're very flexible. Literally any information that is in the platform or any information that can be calculated or derived from the platform can be put into a report. The reports can be customized, so you can have a daily report, a weekly report, a quarterly report, a monthly report, a different report for each site, different report for each user. There's a scheduling feature, so the reports can be generated automatically at periodic intervals of the user's choice, and they can be automatically sent as well too. So this reporting capability has been very powerful and really results in a lot of increase in operational efficiencies. So in summary, a comprehensive AI-enabled asset management platform can provide the following benefits. Can make your data analytics ready by placing multiple sources of data into a data lake, giving users tools to easily interact with, to analyze and interact with the data. Changes the nature of work from reactive to proactive by providing insight into pending issues before they develop. Again, rather than waiting for a pitch bearing to fail and then start taking action, you can be notified 6 months in advance that you have 3 turbines with pending pitch bearing failures. You can start working on getting the components on order, get the crane scheduled, bring them all down at the same time under a low wind condition, and really reduce costs there. Provide improved visibility into the future state of the assets through the predictive analytics model, through the predictive analytics capabilities. Increase availability and production, again, by identifying issues which are having the greatest impact on the particular project. Automate repetitive tasks, primarily here the generation and sending of reports, and reducing O&M costs, both planned and unplanned, by reducing the number of failures and also increasing operational efficiencies. Okay, so I think that's what we have on the presentation. Next, we were going to go to Sandeep, and Sandeep was going to do a product tour of the Energy.ml platform.
Thank you, Rob. Let me share my screen. Just in, to kind of just quickly give a tour, we do want to get into our panel discussion, just to kind of give a little bit better view of what the platform looks like based on what Rob described here. We'll spend about 5 to 7 minutes on just the platform, and then we can switch into the panel discussion with Renew as to how they are using the platform and how it has helped them make their processes more efficient. So Energy.ml platform, as Rob mentioned, is a cloud-based platform and powered by predictive analytics. And to manage clean energy assets, we actually can manage both wind and solar assets. So you can actually have the same view, same platform for both your wind and solar assets. Additional asset types will be added soon. And that allows, again, for efficiency of users not having to now get used to multiple different platforms. We are going to primarily focus on the wind side of the platform, but the solar platform looks essentially the same kind of feel and use of the platform. We have multiple modules on the platform, kind of from an overview, which kind of is telling the users what your current asset state is, different KPIs to monitor, where you can dig into each of the asset. Predict module provides health of the components based on Ensemble's proprietary algorithms that Rob just talked about. Maintain model allows you to get all the maintenance data for maintenance scheduling and planning. And Analyze provides easy access to data with visualization tools and also ability to export data. Reports for, again, report creation, scheduling, and so on. The idea of bringing all these pieces in a single platform is, again, bringing data from one platform to another platform, to a data historian, to some analysis platform, is where a lot of time is spent. And we wanted to kind of make sure that that's not needed for users. We manage all the data. The data is stored in data lake, easily made available to customers. The as such, the platforms, is set up this way. It's very modular access. You can provide varying level of access to users, from executives to site folks to engineering to even external third parties who may just need to get access for data export, and they can essentially go and just get that data export via UI or to an API, as we'll briefly talk about. Digging into each of the assets is pretty straightforward. Each of the KPIs, it's completely configurable. Customers can choose the KPIs they want to see on the platform. It's you want to see ambient conditions, you want to see total monthly production, capacity factor, multiple different KPIs. Here we get few KPIs. We can have many number of KPIs that you could be seeing. This is, again, just for, we are getting that data for predictive analytics, and we make that very easily available. Any of these widgets that are available on the platform are also available for reporting. So again, if there are certain things that you want in report, we'll go through that briefly, where you will be easily able to add that. Managing downtime, a big part of operations is managing alarms and event data, making sure it's reconciled, at the end of the week, end of the month, or so on. 95% of the alarms and events are, even more, 98% in most cases, can be automatically classified, saving users the time to having to go through the alarms and events. And we put algorithms for, most of the OEMs out there. We can classify their alarms. And then there are ability within the platform, easy ability to kind of see, by alarm code, by category, by device. You want to see energy loss, duration, frequency. Again, the data is all in one place, very easily available. The KPIs that you typically are producing, Power BI reports and other things, you can do that within the platform. It's automated way. Ability to reclassify events and do reconciliation at the end of the week, month, is again a piece of cake within the platform. Just availability, again, managing availability, making sure the OEM reports are reasonably correct, and that you have your own independent view of the availability. We do calculate the availability for the assets, and based on contractual requirements, we include all those contractual requirements, and availability is calculated. Kind of from an asset management perspective, right, that's essentially its complete full solution. Alerts, this is an example of kind of the predictive analytics that Ensemble has. In this particular case, we are managing multiple components, or monitoring multiple components through our predictive analytics models. It tells you what the health status of each of the component for different turbines is. In this particular case, the main bearing is in yellow. So this is kind of where ideally you want to take action rather than wait for it to go into red. In some cases, you may not be able to take an action, like we talked about the pitch bearing case, where you are able to see what the problem there is. The machine, in this particular case, turbine 4 and turbine 9, both are in red. So when you are planning for replacement, you can plan for replacement on both of them at the same time. Many times we see cases where a bearing failed and another big component failed later on. You have to bring the crane. You do not need that. Now you can predict what the potential problems are. And there's more details on this that we can obviously go over. If you are interested in you can reach out to us for a demo. On the predict, just quickly on the analyze, we have the ability to scatter plots, trend plots, advanced visualization, like heat maps, comparing different machines, different time periods. Again, all those tools are already built into the platform. Data export is a breeze, as I mentioned. It's a simple UI. You can come in here, you can choose the tags that you want to export, and it's very simply, if it's a small data set you're looking for, will be available within a few seconds. If it's a larger data set, will be available within a few minutes. And if you're asking for a lot more data, it'll send you an email when the data is ready to be downloaded. So again, that data quality is something we are managing. We're making sure that data is analytics ready. So when you download that data is clean, it's you do not need to now spend time to clean up the data and so on. Reports, just quickly, very, very easy to generate reports. You can choose monthly, weekly reports. You can kind of design your own template. You can create new templates, add the widgets that you want, add the information that you want from the platform, and you can schedule that. When do you want to send it? Who do you want to send it? You can have different reports going to different folks. Again, allows for very, very easy management and not having to, email things around and figuring out who got it or not. It's very easy to see that from here, and having ability to kind of customize the reports, what you want to see in the reports, a financial report, a weekly operational report, an engineering report. You can manage all of that in here. So just a very, very quick overview of the platform. I know it was very fast here, but we encourage anyone who's interested to reach out to us, and we can certainly schedule a more detailed demo.
Thank you very much, Sandeep. That was very informative. And again, like Sandeep said, the intention here was not to go through all the features of the platform and to go in depth, but just to provide a high-level overview. Anyone who is interested in scheduling a demo of the platform or really taking a deep dive, please reach out to us, and we will schedule that for you. So at this point, we wanted to turn to a panel discussion. Again, we've got a really great panel here. This is a situation where Renew is a customer of Ensemble. So we saw an opportunity to have a conversation and for Renew to sort of share their experience of what it's been like to use an AI-enabled asset management platform, and how Renew, and more specifically how Renew's customers have benefited from that. So why don't we start that piece now, and maybe I'll kick it off with a question for Nick. So Nick, how do you use the Energy.ml platform, and how has it affected your efficiency and your productivity?
Well, I personally, how I most often use the platform currently is for, live monitoring of the assets and info query, on kind of a real-time basis. If I have a question about what has come out in a daily report or a monthly report or something like that from our field service teams. So I kind of use it to try and answer my own questions and keep tabs on our fleet. Our field team uses it for monitoring, reporting, and downtime allocation on a monthly basis. So it has been a big improvement for us, and I know especially for me in consolidation of all of our platforms into one view, and especially that it's web-based. It's just easier for me to get to. It's easier for me to see everything. And it just, I get my questions answered quicker. And it's actually, it helps me answer my own questions a lot of times. So I spend less time taking up our field staff's time on the phone with me answering my questions. So the more I can keep them working, and the less time they have to explain things to me, that's a benefit for us.
So that's fantastic. I think that really kind of hits on that, improving the operational efficiency. I think those some really good examples of that. I guess another question is, so obviously you interact a lot with customers. And so has using the Energy.ml platform, has that affected the way that you interact with customers?
It has, and I would say we're probably in the early to mid stages of deployment right now. So the kind of similar comments with the customers having to direct access to the same platform that we utilize to report out of, increasing their ability to answer their own questions, and just taking up less of each other's time on keeping everybody informed on the status of assets. That in the short term I see as being probably the first improvement, that I can kind of see on the near term horizon.
That's fantastic. So you're more efficient, your team is more efficient, and your customers are more efficient, all through having that sort of common view of all of the data.
Right, and and again, I'm really kind of speaking from, that's a very kind of day-to-day logistical perspective. That's been my experience thus far. And there's a whole, topic of the predictive analytics that I'm sure we'll touch on more. But
Well,
yeah,
yeah, I mean, now this would be a good time. I mean, can you give some examples or an example of how the analytics of the platform has benefited Renew?
well, again, I'd say we're in the early to mid stages of deployment, but what has already been brought up, and we weren't really driving for this, but we've had a couple of action items added to our list. We've had a pitch anomaly, for instance, on one turbine that was flagged for us. Now we haven't actually done anything about it yet, but that's kind of the point, is that it allows us to put those actionable items on a to-do list as opposed to waiting until something's going to fault and we have to deal with it on a call out basis.
That's all right, Nick. According to our analytics, you got a little bit of time before you need to go work on that one. So yeah, but we're happy that we were able to bring that to your attention, and again, sort of change that from what could have been or what in the past would have been a reactive issue to now making that a proactive issue, which you guys can address when it's the most important thing for your team to be working on. So, well, thanks a lot for that, Nick. Maybe Wade. As one of the things that you do is you direct Renew's remote operations center. So how has the platform affect the operations at Renew's remote operations center?
Yeah, thanks, Rob. Thanks, everybody. I guess maybe to answer that, I might want to back up just a little bit so we kind of understand how the control center came into being in the first place. As we were expanding our O&M business and growing there, it became pretty obvious quickly that we couldn't really do this the way it needed to be done without having a 24/7 operations center. And so that about 3 years ago, that came into being, and we quickly realized that we kind of had two basic duties in the control center. One obviously being the remote operations and keeping those sites running 24/7 and coordinating very closely with our field crews. There's a pretty considerable safety consideration for that coordination. But the other half of it then is providing our customers, our project owners, and asset managers with the information that they need. And those two tasks are quite different. And to be able to do the first efficiently and in a timely fashion, it's difficult to mix those two together. So to provide all that summarized data and reporting for other metrics, having a tool like Ensemble really unburdens us in the control center and provides a centralized platform that has all of those projects together in one view, like you'd stated before, kind of increasing the efficiency for the customers also that have that available to them. It's really saved us a lot of time and man hours in the control center. Parsing through that raw data, we have that data, it's available to us, but we have to, be accommodating to our customer. And, we want to be able to do that as a company. That's kind of our underlying value. And it takes a lot of time to do that. And so as we were growing and as customers' requests got more sophisticated, our project owners are getting more sophisticated, have more sophisticated requirements. It's getting to be more and more work for us, and we don't necessarily have those resources at hand. So when we had the opportunity to take a look at your system and see what advantages it had to offer, it was pretty obvious that it was going to save some time, and we're starting to realize that just within the last couple of months here as we've gotten up to speed with using it. So it's definitely been advantageous in that regard.
Oh, that's really great to hear. Any estimates in terms of how many hours it's saving on a weekly basis?
Well, I would say in preparing that information, just maybe back up a little bit to that process. I'll give you one example with just the basic monthly reports that we need to provide to our customers. With something as simple as just energy and availability, it seems pretty straightforward at the surface. But when you have to look at it in terms of energy-based availability and categorizing that, now we have GADS requirements, other IEC standard requirements that we need to adhere to, it adds a lot of work. And not only just man hours, but you need the tools to do it right. And so just for the projects we were required to do that for, we were probably spending anywhere from 8 to 10 hours a week just on preparing that information and sending it off to the field crews for them to annotate and mark up. And they're the boots on the ground that know exactly what's going on with the project. And so they have to tell us, how that time should be categorized. And that therefore adds more hours on their side. And then to get that information back to us for reformatting again, so that we can ultimately get it off to our customers. It might be several weeks before we can even have the prior month's reports out. And that's not going to cut it when it comes to our customers. We want to be more timely. So that is one, I guess, specific example where we have gained a lot of efficiency, reduced our hours, and being able to turn things around a lot quicker for our customer.
So that sounds fantastic. I mean, great win for Renew in terms of, improving efficiencies and letting your people spend more time on, things that are more valuable. And then, like you said, I mean, getting those reports to the customers faster and really helping with the customer satisfaction. That's really great to hear. Maybe another question. I'm not sure whether this question would be best posed to Nick or Wade. Maybe you guys can answer this. But one of the things at Ensemble that we really pride ourselves on is our flexibility and trying to do whatever we can to tailor our platform to the needs of our customer. And could either one of you sort of talk about the work that we did with helping out improving the plan of the day creation process for Renew?
Sure, I can take that one. Nick, you can certainly chime in also from the O&M side. That's a customer requirement we've had for quite some time, and it is a daily task, 7 days a week, 365 days a year, to provide our customer with here's a snapshot of what your project is doing this morning, and this is what we're going to do about the issues that are at hand. And it is a very regular thing that the field technicians have to take time out. It's usually their first thing that they do when they get to site in the morning to provide our customers with here's what you're paying us to do. This is our job, and this is what we're going to do for the day. And pulling all of that information that goes into that snapshot in order to give our customers a good picture of what's going on is very time consuming. Well, we have all that information now available in a single place, and now have the ability to go in and annotate, put a little more information into the system as to what the plan of the day is for those technicians at that site, and very quickly run a report, either sent out manually or automated, depending on what works best for the customer. And that was a requirement that once we got in and we saw the basic capabilities, it was pretty obvious that this might be something that Ensemble could help us with. We asked, and within a few weeks we got that up and running. We're right in the process of getting it going at the moment, but we're very excited about that. It's been something we wanted to make more efficient for a very long time, and it's become a reality for us here. So it's great.
Well, that's fantastic. I mean, it's definitely very rewarding to hear that. And we're looking for to create lots more wins for you. So thank you very much. So Nick, Wade, thanks a lot for that. Maybe now we'll sort of turn it into the audience Q&A. So please, everyone on the webinar, please go ahead and submit your questions. You can submit a general question, and we can decide which of us will answer it. Or if you want to direct a question to an individual panelist, Sandeep, Nick, Wade, or myself, please let us know. Go ahead and submit those questions, and we'll spend the balance of the time of the webinar answering questions from the audience. So here I got a question. Let me read this. Do you have any case studies on gearbox failures, early detection of failure, confirming via bore scope? If so, are you able to accurately predict the remaining useful life? Can this be done without access to CMS data, or is CMS data required? So, I mean, what Ensemble is really expert at is finding information in signals that we have. And so what that means is we need to have a relevant signal. So typically on the gearbox, if you're not talking about CMS, you do have some information in the SCADA system about the gearbox. You've got oil temperatures. Sometimes you have pump pressures. You often have temperatures on certain bearings. So for those bearings, we can do predictive analytics on those bearings without the SCADA data. But for a lot of the sort of the common failure modes that you're going to see in a gearbox, a planet bearing or a sun pinion, there's really no relevant SCADA data that has any information about that. So in that case, we need access to the CMS data. But thank you very much for the question. If we do have access to the CMS data, one of the things that we are working on, still an R&D project at this point, but we're actually, just like we sort of create a data lake, and just as we bring all of the data together, we're also integrating the CMS data with SCADA data, with loads data, and actually improving the accuracy of the CMS predictions by doing two things. One, adding all this additional data to it, and then secondly, applying the machine learning algorithms as well. Question here, maybe I'll direct this one to you, Sandeep. What are your input signals for soiling analysis? Do you also consider any financial inputs to provide a cost-benefit indicator to decide whether to schedule a panel wash? So Sandeep, that one is for you.
Okay. Yeah. So there's a couple questions in there. So we use different inputs in the SCADA data for solar. Irradiance, we have data for inverter currents, voltages. We understand the layout of the farm, so we take the weather data into account, and that allows us to predict very, very accurately, essentially, what the output would be. And if you think about kind of the deviation from that output, as long as it's explainable with a certain event like passing clouds and so on, the model will not flag that as an anomaly, but will flag something like a soiling, or will flag something like a mismatch as an anomaly. And it's very accurately able to predict exactly what the output should be, right? As for taking into account the financial information, that's typically something that we work with customers to identify how to essentially adjust the notification sensitivity, if you will, and the notification sensitivity can be adjusted by essentially customers, themselves, and they can decide when they want to take action based on the output and by validation in the field. And that's part of the feedback loop, which is very, very important element working with customers. We don't want that feedback loop to happen in email or some phone call, because then that doesn't get captured. And the overall idea is the ML algorithms adjust and figure out when customers want this notification to come to.
Thank you very much, Sandeep. Here's another question, and again, I think this one would be good for you, Sandeep. Is there any additional hardware required in order to use your platform?
No, the answer is no. We do not require any additional hardware. There is enough information available from the SCADA data, CMS data that customers already have, that we can get essentially 80 to 90% of the value that predictive analytics can pull. Now, there might be some specific cases. We work with a customer where a particular component didn't have any relevant information, and they added a certain hardware component. We were able to bring in that information into our platform and be able to essentially build predictive models based on that. So we work with customers if they are adding additional hardware on certain components, but in most cases, it is not necessary.
Okay, thank you, Sandeep. Here's another question. I'll take this, but let me read the question out first. Do you have any specific examples related to how the predictive analytics was able to reduce crane costs by enabling advanced scheduling maintenance activities on multiple turbines? I mean, I can think of a couple that come to mind. And again, my area of expertise is gear and bearing reliability. So yes, I mean, we've had cases where on pitch bearings, we were able to identify multiple pitch bearing failures where we were able to identify multiple pitch bearings which were in the process of failure. so that the customer was able to get all of those pitch bearings with a single crane call out. And then similarly on main bearings, the same issue, where we were able to identify several failing main bearings, which were all able to be replaced by a single crane call out. Let's see, another question here. How long does the onboarding and setup process take? Maybe if you can take that one, Sandeep.
Yeah, it's so the onboarding can be as quick as 2 weeks, and we have had cases where it has taken close to 8 weeks, 8 to 10 weeks. It's based on a few different factors. Primarily the data connection, data transfer from the customer. We support many different kind of data transfer types. Customers, we have direct connection to the sites where we're getting real-time data, to daily data, to sometimes monthly data. So it's a function of essentially primarily the data transfer, data connection setup, building the models, getting it all set up on the platforms. So we have close to 3.5 gigawatts of assets. Most of the major OEMs, it's much quicker for us to do that. So yeah, somewhere between 2 to 8 weeks.
Great. Here's another question that I think would be really good for you, Sandeep. Do you have to have known examples of failures to do failure prediction?
Oh, very good question there. You do not need to have examples. So there are two types of machine learning algorithms: the supervised algorithms and unsupervised algorithms. Chemical components, we have, failure rates, can be high for certain components, but they're not still that many failures. So wherever we have data available and we are able to essentially use the power of data from multiple sources to get to many different failure examples to build supervised learning models. But in case we do not have supervised learning or labeled examples, we actually do two things. One, there is an anomaly detection, what we call unsupervised learning algorithms. We deploy those that can identify, they do some clustering, they identify, automatically figure out if a particular component is different on a machine than other machines on the site, or to compare to the complete database of the machines we have. So that's called unsupervised, and we use that. Or I think the example, Rob, we shared earlier, where we build physics-based algorithms. So we do not need, in this particular cases of when the machines were yaw misaligned, we identify the yaw misalignment based on physics-based models and then deploy the supervised learning algorithm on top of that.
Okay, great, thank you. Sandeep, here's another question. I'm not sure, so one of the earlier questions was about soiling. I think this is actually more broad. So the question is, how do you use artificial intelligence or machine learning for solar performance?
So, just like on soiling, so we essentially are able to identify underperformance scenarios. Now, the next piece is classification. How do you classify these particular anomalies and so on? So this is where kind of bringing the domain expertise comes into play. We have solar experts working with us, identifying particular signals, particular situations that allow us to now build that physics into the algorithm to say, hey, this was a soiling issue, or this is a mismatch issue that's happening. So,
okay, thank you, Sandeep. Here's a question which I will take. Can you only predict mechanical component failures? So the answer there is no. I think one of the use cases that we talked about in the presentation was the power performance. And so that case, it's a turbine behavior. It's not just a component. So we can also identify issues with turbine behaviors. And then with electrical components, it really depends on the particular turbine in terms of what SCADA signals are available. But for a lot of turbines, we have information that we can use for a generator, stator, insulation integrity, and transformers as well too. We have information on transformers, which we can use to predict transformer failures, and some motors as well too. So not just mechanical components. Okay, any other questions, please? We've got a few more minutes left here. If anyone has any questions, we'd be happy to answer them.
Rob, another one I think we got here, I think it's primarily maybe for Renew. Um, as you bring different models into your instance of this platform, does it look like they're treated in a comparable manner across models? Let me rephrase that. Essentially, is this, to Renew is, if you have multiple different OEM models, right? Your customers have different OEMs on their projects. Has it provided you a unified view, or you have to do a lot of customization for it to make work, I guess? I think maybe that's the question.
I can take
Wade?
that one. And Wade,
Yeah.
you can
Yeah, go ahead, Nick.
comments too. I know this is Nick, from my perspective, it has provided a unified view, and it has increased, I know, my personal efficiency at drilling into operational issues, because I don't have to remember how to handle each individual OEM SCADA system. So that's it is unified, and it has provided advantages for me.
I would say too, I've seen some benefit from a training perspective, training operators, at a more abstract level as to, what is common to all of these different OEMs, all of this different equipment, the particular nomenclature in, say, an OEM instance of the SCADA program might be described completely differently from one OEM to the next. But when we standardize that in the namespace that we use to deliver the information to EML, and they kick it back to us in a way that's uniform, we get the benefit of comparing performance at a more abstract level from one project, from one piece of equipment to another project. And it really helps to drive home the basic understanding of how these systems work, and therefore how to operate them more efficiently. So having that common platform is important to us.
Thank you very much.
Great. Just one, maybe my question, that I can ask Nick and Wade, what are some of the future growth plans for Renew, and what are you guys looking at in rest of 2020 and 2021?
Well, we would certainly like to have that one big win and get a major project and have that all, the big slam dunk. But we understand, having been in this business for a while, that it's slow and steady growth, and that's kind of been our strategy. And as we do that, being able to have tools and solutions that the next bigger project and what tends to happen also is those projects are more newer equipment, and therefore with newer equipment comes more sophisticated operations and more sophisticated project owners, and having tools like Ensemble gives us a lot of confidence to move into those kinds of plans for growth. Whereas before we might have been more hesitant about taking on a particular project because we don't want to, nobody wants to fail, and we don't want to do that either. So it just gives us more confidence into moving into those kinds of strategic growth plans.
Great. Yeah.
Thank you, Wade. Hey, another question came in, and let me first address this to Sandeep, and then maybe address it to either Nick or Wade, because it's definitely an operations-related question. The question is, can you perform troubleshooting of faults within the platform, or is the OEM SCADA still needed to perform troubleshooting? Maybe Sandeep, your perspective on that first?
Yeah. So I think the answer to the question is yes, you can perform troubleshooting of faults within the platform. There are, all the data that is relevant typically to faults, say our temperature fault and our current fault and so on, is available within the platform, and you'll be able to easily pull data, from the platform to do your analysis. As I mentioned, you can do it directly on the platform. You can use an API to quickly export data in a Python code or so on to build, any kind of analysis that you need to do.
Thank you, Sandeep. Wade or Nick, I don't know if you guys have anything to add to that.
Yeah, this is Nick. I would say what I think that question is driving at is that our field level technicians do use the OEM, native SCADAs to perform command control type troubleshooting. And as Sandeep was saying, the Ensemble platform, we utilize that for the more trending and analytics and problem identification. But what I think that question might be referring to is the nitty gritty, can this be reset, type of field level trouble.
Yes, so to kind of maybe, the reset or the control of the machines is not something that is currently possible through the platform.
And I know for me, it's great to have that separation, so that there's a tool that has no command control, that is purely for analytics and reporting, and there's control of work type of issues that are kind of cleaned up, since that's the architecture.
Perfect.
Thanks a lot, Nick. Well, we've reached the end of the hour, so I think we're going to wrap it up. Thank you so much, Wade and Nick, for participating. It was really great to have your perspective on this. Thank you. We really appreciate it. To all the attendees, again, thank you very much. We appreciate your sharing your time with us. There's a question that you wanted to ask, but you weren't able to ask. Please reach out. If you'd like to see more of the platform, please reach out and we will schedule a time to give you a tour. Thanks again, everyone, and enjoy the rest of your day.